Okay, so I thought I'd go through some more things. Um, kind of some compiler stuff and the specific kind of architectures that we're kind of using. Um, GHC. Compiler and a driver. So I guess the driver is just the kind of wrapper to actually do the shit. What's compiler GHC versus language Haskell? I guess this is just the parser then, and this is like the actual wrapper. Let's see, files like unit.hs, systools.hs, etc. core.hs, core to interface, LVM. Ah, okay. Haddock. I think that's just the stuff, the low level LVM kind of crap. Unit. Even there's a parser in the unit. By the way, is there like a core or anything like that? Got a core.hs. Here. What? Coercion, lint map, opt rules, type constructor, I guess, but type co? Hell is that? Tycon. Niggas. Alright. So I guess this is like the main parser or what? I think they have their own kind of parser combinator. They're not using like parsec or anything. Although you could probably rewrite it in parsec. So yeah, here they're kind of defining their IR for the core, where you have variables, literals, applicatives, I guess, lambdas. These are just functions. Applying some function B to an inner expression B. Is that how that works? You're binding a variable B to the expression. Whatever is the result of that, I guess. A case or match, I guess. Cast, tick, type, coercion. Um. Did I accidentally mute myself? No, I didn't. Okay. Um. Wow, that's just one huge fucking block of commenting. Oh, really? You gotta be kidding me, man. They don't even support Haskell. And Haskell would be probably one of the easier ones because, you know, you only have like functions and shit. Just every time you see like an equals, you just kind of like, you know, just do that and then try to find it in the same file if you can. Type or whatever. Um, yeah. And I guess a lot of this stuff is probably just wrappers as well. Mm. If it is certainly the case that the unfolding will yield a value, H and F, Haskell normal form, false if unsure, and here we're kind of matching on the type, like if it's a core unfolding, or a defun unfolding, I guess. I mean, okay. Yeah, because, again, it's such a big thing, and you have this thing like expressions and make int lit, I guess. Literal. Wow. And again, all of this because they want to have like a they want to have it working for all sorts of platforms. I guess it probably makes sense. Make construction applicative. Oh wow, that parses into core. Oh. Now Haddock is just a Haskell documentation, I guess. Okay. Check what's on the list wrong. Eh. Got me like changed it. Whatever. This implements data bits. Okay. That was STG. Okay, so you're taking in these kind of things and you're returning in a bytecode. Hmm. And again, I don't really get it. Why do they have another kind of syntax thing? I mean, is this like, did they just forget about this or what? Maybe for Haddock or whatever? Oh my god. Can't wait until everybody dies, man. Let's play some. Jeez. They have like a billion different modules, and some of them look like they're duplicate modules that are doing the exact same thing. I'm not sure if it's just for like a Haddock thing or what either, because it seems like it's been recently updated as well, at least the syntax. Um, but the parser itself isn't, so. What a fucking mess, I mean. So hopefully that kind of showed you how much crap is in modern compilers. Oh, really? What's that? Oh, GPT-4 all. Is that even good? I guess it's just kind of like asking questions by scanning it. I guess that's probably good. So you would have to do that, and then you'll ingest, and then start asking questions. So. How big is this? Oh, alright. Oh, 3 gigabytes. Damn. Okay. Alright, might try that later. Oh, really? This work for. Clicker. Oh, is it that one? What? It's the same one as this? Wait, do they not have a brew? That's pretty annoying, but oh my god, that's actually annoying. So why would I use that when there's this? Maybe this is not as good. I actually don't know. I mean, but I will. I kind of like this idea. I might just try it out. I hate Goog so much. Oh yeah, you have to kind of like X actor. That's cool. And Warp has been very good too. Ooh. Yeah. Look at that later, maybe. Um. Ooh. C3 is a pretty good language. It's good. All right. Do we want to do some? Let's probably delete this shit first. Hmm. Um. Is it not working? Okay. Sometimes it takes a while for the language server to start up. Hmm. It's kind of trying stuff out on this language here. I kept kind of changing the idea of it. I thought I'd just kind of settle with a parse tree at first, and then I'll maybe descend the parse tree and I'll create a sim tab. And so yeah, basically I'll return an env or sim tab or whatever. Um, mm. It also is very nice to do this unwrap. Maybe I should just create an unwrap macro as well. Uh, just get unwrap. So yeah. You basically find the call expression. The call expression probably just looks something like, you know, F or add or sub 2, 3. That's going to give you -1, sub add 1, 1. That's going to give you 1. Yeah, it's about right, I think. Right. Pretty good soundtrack. So yeah, you find the function ident, and I guess you just keep trying to find it, I guess. Which is probably going to require recursion. On a language like Rust, I think it is actually kind of awkward to do. Which is kind of one of the reasons why I'm kind of like hesitating quite a bit here. But yeah, look, I mean, then you can match. You know, if it's an env, recurse, find, ident. So you can just eval call again, I guess. That's your kind of recursive case, and this is your base case. Oh yeah, I moved it. By the way, I think find actually does that for me though. Or it either finds the value itself, and the value should be a value rather than an env, I think. Is that how that's supposed to work? Oh, okay. Okay. Oh, fuck. Okay. Well, that's annoying then. Fuck, 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 fuck. And the problem is you can't, like, have, Yeah, it's hard to express what I want, elegantly, which is really annoying. Because I want, this to kind of store an env, but I also want env to kind of mean env or that. And I guess you could just have env as an enum. Just do that. But fuck it, that's annoying. I don't want to do that. I mean, yeah, and especially since the value itself is going to, like, it's so annoying. Um, do I want a hash map, or do I just want to store another env? Yeah, I guess we'll just do that. And this is just kind of like the mapping, right? So we could kind of just go. It's just rust. Then you have to match self. Although technically you could probably just have a. I think that's how that works, right? Oh, come on! What? It's probably a much better way of doing this. I don't really give a fuck. Uh, self and match self. Here we'll just kind of go like, look, you know, if it's an env, then clearly we have to find a gain. So basically, like mappings dot find s. So that's our recursive case, I guess. Fuck. Dot get. And again, if it's resultant value if ID, just return that, I guess, or just match value. We need an OK of value. Wait. Can't you do that? What? I'm pretty sure we can do that, right? Yeah, I'm pretty sure we could do that. Unless we have to like borrow this as well. Oh, okay. So here we'll kind of have to go like self-iter, I guess. Oh, like this, I think. Um. Wait. Wait, what am I doing here? I'll find. What's env here? Map env. Boom, 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 boom. So I guess we don't even have to do this, I think. Gook. Color. Fucking gook ass nigger. Just kill him. I think we'll just m.1.find, I guess. Um. Okay. Okay. Match. Wait, can you just do that? So yeah, fair. So if we have a recursive case, we kind of check if we could find a value for which this is equal, I guess. And if it is, then we return that. Otherwise, we can't. I think that makes sense. I'm not entirely sure if that will work. Let's try that again. In value. Alright. Val. So this is how we would store values in a table like this. How would we store a Oh, come on, man. Did I put S somewhere? Can I just do that or what? Gotta be kidding me, man. Fucking hell. Maybe I should just make this like an... Blind. What if I clone it here? Maybe I have to clone it earlier? Yeah, okay. Like, I guess I could have just used a reference, and then maybe I can clone it here. Yeah, I think we'll just use a reference then. Here you can just kind of go. So do we want to just change table and so do we want to change the way, like, what kind of values do we want, right? Do we want like a callable or something, like an add or like a primitive function? Um, oh, yeah. Oh my god. I mean, this should be automatically like done, I feel like. Funk. So here then we could kind of like, wrap that around and oh my god, man. Like, and again, it's just these small things in these fucking languages. I mean, I don't even have to want to use Rust if I didn't have to, but this is probably like the language that's got the best support right now and isn't like completely annoying to use versus other languages. So I mean, you kind of just have to stick with it, I guess. I think Clojure wasn't too bad either, but didn't really want to move to that because, again, like if it's going to compile in this language, it's just going to work, I guess. So it's whatever. But yeah, guess we can do an impl. Exec, I guess. Maybe a vector of value or some shit. Self match self. Fuck. All right. So if you want to add, then we'll say, look, args dot to iter dot fold 0, I guess. And here, I guess we'll have an accumulator, an x, and it's simple as that, I guess. I mean, there's a bit of redundancy that we could. Yeah, I don't really care. Whatever. I guess I could probably, Okay, looks pretty good to me. So once we get to a primitive function, that's when we can start to apply our thing to our args. So args. The problem is I want args to also kind of include I64s and stuff like that, I guess. So that is a bit of an issue, especially kind of like the parse tree. Match expression. I guess I could convert the parse tree into a lower level tree that already has the bits there. I don't even know how that's going to work. Otherwise, I'm going to have to like recursively call each arg as well, exec each arg. Um, so that's going to return like a value, I'm guessing, like an I64. Because everything at the end of the day is just bits, right? Always return. Hmm. How the hell is the calls are? How the hell are they gonna work? I guess they're going to have indirections, and they're probably just going to work like that. Fuck, that's so annoying. Uh, Yeah, because the way that Rust works, they don't have the variance of a discriminant of an enum. They aren't actual like types in themselves, so you can't really do anything about that. But the idea is, look, you have your I64s, so now you can kind of exec. Can you collect? Can I do that? Oh, oh, wait, yeah. This could just be. So, I guess that's a very kind of simple way to do it. Not a valid. By the way, I think this works, right? Yeah, tried my kind of experimental interface here, but to be honest, I didn't really like it. I think I'm probably just gonna archive this, because I think it's just over-engineering and adding, like, unneeded complexity. Alright. Implemented primitive eval. Because each kind of argument, if you have like f of arg1, arg2, arg3, and even if arg1 is, I don't know, u60, if it's a primitive, that's good. But if arg2 is a call, that's going to result in a primitive, right? Arg3, same idea. So you kind of have to evaluate each of the arguments first. That's going to give you a primitive, aka an always return type I64. And with the I64, then you could actually start to execute that in that kind of manner. I was trying out some data flow stuff here. I don't know. I'm not really sure what I want to do there. I mean, I think I might look a bit at vectors and spinal HDL. Rock. Probably have something similar. So let's create a register. Uh, where's the fucking reg, mate? Do I want a uint? Yeah, probably. For really, is that how you do it? Does that actually work? Uh, let's say we have 2 lanes and 16-bit width. Oh, okay. What happened? The hell? Is it because it's fucking Verilog? Okay. I didn't know you could do that. So bits is a function, so it's almost kind of like saying dot bits, I guess. But I guess that makes sense. And this has probably a higher precedence, but just to make sure, I guess. Um. Oh, out. Like an out dot register? How do we do this? I mean, we could do that. Or maybe vec. I mean, I don't know. Maybe uint or what? I mean, of 2. Does that work? Okay. That's your instruction. I think I'm gonna call it out rather than output. Um. So I guess this will be the same thing then. Oh, so no, we only have 1, I think. Can we do enums or? Uh, Vector instruction. Uh, Oh wait, sorry. How the hell do we use this? Like in.enum maybe? Coding. Hmm? Does that work? And maybe we can just interpret the bits as that then. So in SIMD, you're either doing element wise or array scalar. So you kind of have two kind of ideas. V1 plus V2, for example, maybe like 1, 2, 3, 2, 3, 4. One, two, three. Plus 1. I think we're going to assume it's mostly going to. I guess we can do two of them. Vector, scalar. So we either apply plus 3 to each element, or we kind of do that in tandem. I guess this is kind of similar to kind of doing 3, right? So 1, 2, 3. How does vec work again? So that's one way to do it, I guess. Hey, so it's always element wise, I guess. We could have like because you could also have like a convolution, something like, I don't know. That's a bit different to, your thing. I guess that would have to be rearranged into a sequence of um, element-wise kind of operations then in the compiler. By the way, does this really not work? Could it be this? Oh. God damn it, man. probably come back later. But I think the idea is pretty sound. That matches to this. Oh, okay. So I guess it kind of just returns this, right? God, man. That one's possibly could it be? Oh. Oh, okay. So when you're kind of doing this, I guess it's matching on the decomposition. I didn't even know you could do that in Scalar. I guess that's probably one of the best things with Scalar and why you would even use it in the first place. It's much less annoying than Rust. Rust is super annoying. Alright. Alright, I hate all the languages. Maybe let's check this. What? Is criterion. So we have to define our criterion and then we have to train our data basically. Fucking stupid and ignorant masses. Yeah, it's not my problem, it's the fault of the masses. I'm not going to get too mad about it, I guess, right now. Anything else that's cool? Really? If you have some open kind of like things, I guess, in your code base. BDD, BTD6. Um, Everybody's so like retarded that it is what it is. What's this? Is this available? Nope. Alright, well. Oh. Mandelbrot. Can I see like example spinal HDL project? Maybe like a CPU or what? Oh, VexRes 5? Oh no, that's just the okay. Oh really? Okay. So this isn't even like a component. He's just kind of like, okay. He's just defining his kind of configs here. Doesn't care about, so these are the instruction kind of things that he's implementing for RISC-V. You have a bunch of don't cares. You have your kind of like opcodes and, secondary opcodes and crap. Yeah. I think for certain instructions, those are like registers and shit too. Sign, immediate, or modifiers and stuff like that. And I'm looking for something like nameable. Is that a spinal thing? What? Why is he extending nameable himself? What the hell is he doing? What? Hard type with nameable. Because that's another like spinal HDL thing. Man, am I getting trolled or what? Yeah, I don't know. Unless it's probably is a spinal thing. By the way, I think I actually downloaded a doc set for that. So. Oh no, but that's the bad one I think. HDL. Uh. What's this? Uh, um, alright. Java native interface. Area. Okay. 10 months ago as well. Oh, that's very nice. Can run at pretty high megahertz too. Nice. Right. Wow, look at that pipeline. 5-stage pipeline. Probably quite good. Can I find the FPU somewhere? Resource hex. Oh, they have their own emulator. Um, IP maybe. Oh, here we go. Okay, so here's his component. There we go. Right. Is he going to be using this somewhere? Oh, okay. So he's actually creating the register with the thing at hand. That's actually pretty good, I think. So with this state, then he could change the state. Um, and kind of set the state like that. With RegInit, you kind of have like pretty much an implicit variable on locally. That's how they try to do it, I guess. How old is this as well? On square root. Wow. They have to they have to set a whole bunch of crap. And then, look, match on nan. If nan is true, then they can kind of decode and set nan quiet. Set state idle, input ready. This kinda legit. Okay, I'll probably look at this a bit more later. But that's pretty cool.